To understand how our senses work, there are three specific terms used. Stimulus, which is a source of energy that initiates a reaction in our sensing organs. Sensation, which is the initiation of sensing organs in respect to the stimulus. And perception, which is a recognizing function that occurs when we sense a stimulus or an outside force. We use perception to sort out the sensation. For example, listen to this sound. What is this sound? When the sound played, your sense of sound was activated. That was a sensation. If you classified the sound as a bell, you use perception to distinguish the sound. To notice the stimulus, there has to be enough present to be detected. The smallest amount of a stimulus that can be sensed by a sensing organ is known as the absolute threshold. As humans, our senses are very keen for our survival. Under perfect conditions, the sensing organs are extremely sensitive to outside stimuli.
Oh my god!
However, most of the time, perfect conditions aren't met. Usually noise is present. Noise is an interfering source of energy that is not specific to sound alone. For example, that when focusing on driving, there are times when the sun's light is obstructing your view of the road. The excess of light is blocking your vision and thus considered to be a noise interference. Looking at two similar sources of stimuli, psychologists like to look at the smallest amount of difference present for us to detect the change. This subtle difference between stimuli is called different thresholds. In simpler terms, a just notable difference. As we are exposed to different stimuli, at first the sensation may be painful or very strong, but shortly after you adjust and the sensation isn't as overwhelming as it was before. The adjusting ability our brain has is known as adaptation. The adaptation is in a way similar to an exhausted message carrier. Our brain receptors are the messengers. When we sense an overwhelming sensation, the messages are shot to the brain very quickly. However, the messengers become exhausted and eventually get to the brain at a very slow pace. This process is what causes the lessened sensitivity.
The images we see are rays of light being reflected off to our cornea. Then they pass through the focus and travel through the... Once the light travels across the pupil, it enters the lens, which act to bend and reverse the image to focus better on the rear of the eye. Once the image has reached the retina, it is the optic nerve's turn to send this image to the brain in the form of electrical impulses. Color blindness is the inability to distinguish the difference between certain colors. This condition results from the absence of color-sensitive pigment in the cone receptors of the retina. Approximately 1 out of 12 men and 1 out of 20 women are colorblind, and the most common type is red-green color blindness. We have two pairs of color receptors, which are the cones. One of them is the red linked with green, and the second one is the yellow linked with blue. So if we stare at an image for a long time, we're gonna wear out one of the pairs and the second pair is gonna take over the image. To experience the opponent after image effect, stare at the dot located in the center of the image for 30 seconds and continue to fixate on the dot after the picture changes.
What's that sound?
What sound? Well, sound is just molecules in the air moving to a pattern of vibrations.
What? Who's talking?
Me? Well, you can call me Module 10.
Well, I don't see any vibrations.
Well, not all is visible with the naked eye. Some are detected only by...
That's the sound.
Yeah, and for this, you can actually see those vibrations. Yep, but most of the time you can't actually see those vibrations. But in our ear, we have an organ called the eardrum that senses those vibrations. The eardrum picks up the vibrations and sends it to the cochlea, the snail-like feature. It has fluids inside that respond to those movements. Then those movements are read and sent to the brain.
Why are some visible and some are not?
Well, because vibrations have different patterns in which they move fast or slow. They're known as frequencies. Low frequencies have smaller amount of waves that happen per second. That's why it's a lot easier to see the vibrations in low strings. Whereas the high strings, the frequency is high, meaning they move faster per second, making it harder to see.
Okay, well, how does our ear detect if it's loud or soft?
Well, it's kind of the same thing as frequencies. Long drawn out waves create low sounds, and soft sounds have patterns that are sprawled out. This is what's known as the amplitude. And these sounds amplitudes can be measured by a system called decibels.
Ow! That hurt.
We're also more sensitive to other sounds more than others depending on how high or low the decibels are.
Does that mean our ear's like a microphone?
Yep, well, that's what the frequency theory of hearing suggests. But there's another theory that states that different parts of the ear are responsible for different frequency. That's a place of theory hearing.
And they'll be like, no, I just don't want to.
Oh, yep, and ears aren't only for hearing, they're responsible for balance too. Okay, well, the fluids in our ears, more specifically in the semicircular canals, signals rotation and angle movements to the brain, allowing us to move forward, backward, up and down, and keeping us balanced, just like the gyro ball.
Smell is the second most used sense to retain information. We make associations with smell and memory. For example, a diaper full of brown stuff, one would assume it is fecal matter because of our previous experiences with diapers. In this experiment, we filled diapers with chocolate. It is the participant's memory that it will determine his or her reaction to the smell. Taste, also known as gustation, is a sense that uses taste buds which hold 5 different taste qualities: sweet, sour, salty, bitter, and umami. Umami is a savory flavor usually associated with meat. Anything with MSG is umami. The 5 tastes interact to allow multitudes of flavors. Taste buds are distributed throughout the whole mouth and they reproduce every 10 days so we can continue to experience flavors. Skin senses. These include touch, pain, temperature, and pressure. Our skin senses provoke awareness to our environment. The skin receptors are diffused throughout the whole body. Some areas of the body are more sensitive than others. For example, the fingertips, lips, nose, and cheeks are very sensitive. Pain is an unpleasant, harmful sense we feel when cells are dying. For example, when Peter falls, he sustains cell damage. There is a way to control pain as well. If you interfere with the pain by overwhelming it with another sensation, for example, when Peter holds and rubs his leg, he is using the sense of pleasure to fight the pain. That's loud.
Yep, and we're also more sensitive to other sounds more than the others, depending on how.
Recording no.
It's chocolate.
That's nice, but no, just please cover it up.